By the end of this section of the course, we want to be able to produce the graph of a polynomial function using algebraic attacks, right? And so we know about zeros, that's super important, and we can of course find the intercept, the vertical intercept too, okay? Horizontal intercepts are the zeros, so we've already found those. We've talked about order of a zero, that's going to be very useful. And so next what we want to do is start to see how those zeros come about, and zeros and their orders, I should say, come about in connection to the graph. So we're going to look at Desmos, okay? And yep, there is a summary here, but we'll come back to it and talk about it in more detail soon. So here's Desmos. I have just y equals x to the n, and then we're going to change the value of n and just kind of look and see what happens. We're focusing right now on the zero of this function at 0, okay? So the 0 at 0, and then kind of looking at the shape of the graph. So if n is 1, so this is just y equals x, right? Plain old line. The function at 0 intersects, certainly, and crosses through. If I change it to 2, what happens? This is our basic graph of a quadratic function, right? So at the 0 at 0, right, what happens graphically? Well, it's going to intersect and then kind of rebound, okay? Let's look at another one at degree 3, okay? So degree 3, well, okay, so in comparison to 2, okay, at like 2 it rebounded, 3 it goes through again, intersects most certainly, but it gets a little bit more flat, and then as I go to 4, it's getting flatter near 0, but again, it's still doing that basic like parabola type behavior where it's touching, but it's kind of rebounding on either side. Okay, so let's see if I'm going to skip to 6 and just see what happens. 6, okay, touches, flattens, and what about 8? Touches and flattens, and rebounds, right? Okay, so that seems to be the behavior, and I could check at 10. Yep, pretty flat. And then it rebounds too. At 5, again, this looks a lot like the cubic where it is going to touch most certainly, go through and flatten. And then at 7, it's even flatter, around 0, but touches and goes through. Okay, so it seems like if we were to summarize this, and it's shown on the screen here, I'll zoom in. If we look at the 0 of a polynomial with a certain multiplicity, again, multiplicity, another piece of language for that is order, okay? If the order or the multiplicity is odd, it's going to cross through at, crosses the x-axis, and I'm just going to add a comment here, at x is equal to c. So whatever the 0 is, it's going to cross through, okay? If your multiplicity or your order is even at that 0, okay, then it's going to touch the x-axis at x is equal to c and turn around, okay, so rebounding, right? And then whenever your multiplicity or your order is greater than 1, it's going to flatten out, okay? So if your order is greater than 1, it flattens out, okay? And obviously the larger the value of m, the flatter it gets. Okay, so we kind of know about behavior near zeros. What about away from zeros, or maybe in between them? Okay, well, by definition, the 0, it means that the function is 0, right? So literally like f of c would be 0, and that would be all the places where the function is 0. Okay, thus, if it's 0 at 0, or sorry, if it's 0 at these values of c, then everywhere else it's either positive or negative, okay? And so what I would say is, how do you know if it's positive or negative? Take some test points. Let's see an example. And this example will actually carry through several videos here. So we have a function, we want to find its zeros, okay, and then we want to sketch a graph that shows its zeros and its behavior near them. Okay, so this one should factor by grouping, okay? So I want you to pause video, try and factor this, and find its zeros. And here's what I got. So I did factoring by, or I factored out the GCF first, and then it is factoring by grouping. So I grouped those two. Okay, proceeded, and then this had a factor pattern, x to the fourth minus 81, that had a factor pattern of x squared minus 9 times x squared plus 9. X squared minus 9 factored further, and so it was some intense factoring, but at the end I got x cubed times the quantity x minus 3 squared times x plus 3 times x squared plus 9 is all equals 0. Okay, and then the zeros here are going to be 0, 3, -3, and then this one actually has no real zeros, so I'm just going to omit that one. And so I get the zeros, and then I also listed their orders just so I'm aware of those. Okay, so I found the zeros, and so if I'm thinking about a graph, again, my job is going to be to kind of sketch the graph. I know I'm going to have a 0 at 0, and then at plus and minus 3, plus and minus 3. Okay, I'll maybe go out to 5 just for fun. And there we go. Okay, so I have a 0 there, 0 there, 0 there. Okay, and so now what do I know? Okay, that's about it. Okay, I know that this is going to cross, this is going to touch and turn around because it's even, the order is even, and then here it's going to cross as well. Okay, but I don't know if it's crossing, when it crosses, I don't know if it's crossing from the positive to negative or negative to positive, or if it's when it's touching and turning around, if it's from positive to negative. And that's where I would say let's make a little chart. Okay, so I'm just going to make like an x and an f of x chart. Okay, so I know at, -3, it's going to be 0. Okay, and maybe I'll do a number line. I'll do a number line. So this is the x-axis. 0 and 3. So this is the x-axis. And up here, what I want to list is kind of the value that f of x is. So I know here it's 0, here it's 0, here it's 0. Okay. Now I want to maybe take some other sample points. So let's take a sample point of -4. In this interval, I kind of want to do it in each interval between the zeros. So -4, -1, let's do +1, and we'll do 4. Okay. And so now I just need to put those into each of the into the function and see what happens. So -4, if I do, and so I would get a calculator out and calculate these values. Now I'm not going to do that. What I am going to do is just determine the sign. So is it positive or negative? That's really what I just need to know. At -4, I get a positive value. So I get a positive value, so it's greater than 0. For -1, I get a negative value. At +1, I get a positive value, and at 4, I get a positive value here as well. Okay? So here's what I'm thinking. At least when if I were to make a sketch of the graph here of what I know so far, at -3, I know it crosses through. So it's going to cross from positive to negative. So it does something like this, from positive to negative. Okay, I have no clue about the vertical axis. I'm not even going to guess there. But then at 0, what do I know? 0 has an odd, and it's greater than 1, so it's going to cross through and flatten out. So it's going to kind of flatten out like this, cross through, and then go up something like that. And then at 3, what do I know? So it's going to be positive on the right side. And at 3, what happens? It touches and turns around. So it comes up, maybe something like this. It's going to flatten out and then turns around and goes up like that. So something like that is how it behaves at and near the zeros. So how did I do that again? First of all, I found the zeros and I looked at their orders. Okay. Their order is going to tell me whether I cross or touch and turn around. Okay. To figure out where like how exactly it crosses and or turns around, that's where I looked at the function value. So I made a little number line. I put my zeros on there. Those are in red. And then I just took test points. -4, -1, 1, and 4. Anything that's on either side of a 0. Okay, those are x values. Okay. Then I looked at the function value. Was it positive or negative primarily? It was positive, negative, positive, positive. So then I made sure to replicate that positive, negative, positive, positive pattern that I found in my sign chart. Okay, and that's at least enough to give us a general idea of what it might look like. Exact values, we'll leave those to a graphing utility. But there we go. So we have a little bit more behavior, or a little bit more understanding of how zeros are so important and how that is reflected in the function of the graph of a polynomial function.